every time I'm talking to people. I shouldn't do that. Not a good idea. All right. So sorry, delay again as usual. So, Jason, first of all, what do we need? Summary, or what do we need for any sort of REST interaction? We need to know UL. We need to know the content type. We need to know the structure of the body. How we figure that out? N ways. Either looking at the web page of the respective service, getting GET requests and just seeing what you get back and emulate this and use it. And the status codes, of course, right? So that's basically the idea, and the response structure similarly, of course. Of course, the response can be different. The response body can be different from the GET body. So the one thing to highlight here, though, is that different request types have different implication with respect to URL, right? So we saw that for the posts example right now. Thank you. So if you want to post a new post, for example, right? Assuming you make a post request like this, and here's the URL and so on. This is the path post. You would post the structure against posts, so the root URL. The reason is you wouldn't know the ID under which your post will be, registered, right? If you, however, want to get a specific post, you would identify the post accordingly, right? So posts, and then let's say 1 or 15 or 255, who knows? If you want to get all posts, you would simply say get posts, right? So why am I pointing this out? Because it's a difference. In one case, you're retrieving one individual item. In the other case, you're retrieving all items that the service provides, right? So sometimes the semantics of different methods, different GET requests, depend on what you want to do, and actually just require you to modify the URL accordingly, right? You can't just oh, I want to get all, I want to get one individual. Well, it boils down of what URI you specify, right? If you go to the root URI, the endpoint, as they call it, in the API, posts, then it would give you all. If you specify a given post, it most likely end up with one item. So that's important to bear in mind, because that if you use publicly available services, that's something that you will trip over repeatedly, I'm very sure. So it's something to bear in mind. This is basically just a placeholder reminder. Okay, so we talked about JSON, but never really talked about JSON, right? So which is not really nice. And I know some of you know JSON, but the majority hasn't had any exposure to it yet. Who wants to give a go and take a crack at JSON? What is JSON? Who feels excited talking about JSON? And what does it stand for in the first place?
I can. JSON stands for JavaScript Object Notation, and it's basically a quite dense way to send the data you send. It has little overhead for it, and if you go on JSON.org,
Bit louder, yeah.
If you go on JSON.org, you get a really good representation of how it's made.
Yeah. So
basically, just a flowchart. You just can.
That one, right?
Yeah, basically.
Right. So yeah. So what you mentioned is pretty much correct. So the idea is focused there. It has two properties. One of them, it's reasonably efficient as a representation, but I'm saying reasonably because it's human readable, right? A binary representation would of course be better, but the idea is here that it's still human readable while being structured and while being efficient. So it's an alternative to XML in that respect. I'll probably have another session where I talk about XML and the pros and cons. You triggered me. But fundamentally, it's currently the way to go, I guess, to interact with web services because of its efficiency that it has. But fundamentally, what can you represent in JSON?
Anything.
No.
Whew, that's a tough one. Okay. But I like your spirit. That's right. The spirit is good. Anything. So what can you so moderation? You had.
Well, you can't have duplicates of keys in your lists, or like you can have two things you want, like you can and
So what can we actually represent? Like what are the kind of data structures you know about we can represent in JSON?
Basically hash maps and lists.
Yeah.
And you can have any values on the right side in hash and
Yeah. What else can we represent? There's something else. Hash map list is cool, yeah, and something else.
You never said what JSON is. You just
Well, let's talk about data structure and we look how they're represented, because you heard about data structures before. Hash maps and lists make sense, please? Anyone?
Hash maps.
Oh, maps make sense? Maps? What is a map structure? Yeah?
It's a key value, like it's a structure where you give it some key and it turns out some value.
Yeah, right? So we're dealing with, I think, 3 basic structures in any case. So maps is probably the most sophisticated one. It's generally something like key value, right? So for example, in the country code example here previously was name and then Norway, right? So for a different country, it would be the key would be the key would be the same, it's also name, but the value would be Afghanistan, right? So Albania or whatever else, right? So key value associations, right? You learned about this some sort before, right? Yes. Good. The other one is lists. What's the difference to lists?
It's just counts from 0 and the values.
We basically just have values, right? So get rid of the keys, so we only have values, right? A list of values, 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 but no characterizations, right? So it's just whatever, numbers, strings, or whatever, right? So no semantics. Whereas in maps we have the association. So what's the third one? So we have lists, we have maps, and what's the third one? The basic structure. I mean, it's called JSON for a reason, right? JavaScript object notation.
So that's the same as the hash map.
It is the same fundamentally as the hash map, yeah. But what does it represent in terms of? You're right, but not quite, because the representation is slightly different as well, right? So, but at the core. Yeah. Okay. Older version of object, like the yeah, struct.
JavaScript object is hard to define.
It is.
Both an array and object is an object.
Exactly. So it's not really uniform. But we generally think about structs, I guess, right? So the basic structure. So you can represent a struct with a uniform representation of a student, right? Consisting of a student name, a student an age, and the study program, right? So that's a struct, uniform structure. And if you have methods attached to it, it's an object and all that kind of jazz. But we're only dealing with the actual structural information, right? So, and that's fundamentally what it is. Well, what can we represent in JSON? We can represent different values and value types. Fundamentally it. And that can be a string, a number, an object, an array, true, false, or nil. And yeah, so the idea is always that we have opening parentheses. Then let's use the standard struct notation. So I'm using the example of a student. So we have some sort of key. Note that the keys are in quotation marks. It's important, right? So we need to get that right. And then we have some value associated with this, right? So my favorite student, Lars, okay. Which also, because it's a string, guys, you know that, so you can help me correct this, my syntax thing here. But so last is a string, so it needs to be denoted with quotation marks as well. Then let's say the student has an age, where everything that's a string, of course, needs to be denoted accordingly. And let's say the age is a numeric value. So do we support numbers? Yes, we do. That's good, lucky us. And his age is, 18, pretty young student. What other properties do we have? Well, we can suggest that he's signed up for the course, and that's a true value, lowercase true. And what else do we have? So I'm saying in the literal values, true values. So okay, I think that will roughly do. So this is basically a basic JSON structure, right? So we have a representation of key value pairs, and they are concatenated using commas, and they are surrounded by curly braces, right? So that's the main notational characteristics, and that's pretty much it. What the structure is all about. An extension to that, can we do two following things? We can represent an array or list if you like. So we can do things like So if we have, for example, a course representation, we could have here a course ID. This would be IMT2681, for example, separated by comma, and then we want students and if we want to represent those students as a list, for example, we can do so in the following manner, that we actually have a nested set of students. We have Lars, we have Tom here as well, most likely. Yeah, so any name that comes to mind, Bob, and so on. So this is kind of an open-ended list, and then again signified by the squared brackets. They indicate the end of the list of array. So that's the kind of syntax they chose. So either you have individual values of string, numeric type, whatever else, and if you want to represent lists, you kind of surround them with those curly braces in order to signify that they're lists. If you want to, for example, have a nested map, which you can do as well, you would do similar. You would basically just have a nested curly brace, and then can use the same key value structure as before. A key is always a string, and the value can be of all the values that are previously outlined. Any of those types can be a string, a number, an object, array, and so on, or a Boolean value or nil, or null rather. Sorry. So that's pretty much what the entire structure is about. So if we look at some examples, it's probably a bit more accessible, especially given my handwriting. Let's bring up this again. So if you look at it now, if you look at this structure here, I'll bring up the magnifier again. What structure do you recognize here in this output? This was the post service I just used before. So what how would you describe the structure, please?
Can you turn on the printing mode as well?
Oh. Isn't that pretty? I think it's as pretty as it gets. No? Sorry? The
printing.
Whatever.
Yeah, this is better.
Okay. Ah, right, the color coding. Yes. Thanks, I didn't get that. Right, colors, guys, come on. But yeah, good point. A list of, yeah, correct, right? So who agrees? Who disagrees?
Well, Gakunir was
a list of maps was a suggestion, right? So we have the square brackets on the outside here, right? And then we have a set of different entries separated by commas, and they are fundamentally maps, right? Map structure, key value, right? User ID apparently seems to be a number because there's no quotation marks around it, but that's roughly as far as the typing goes. It's just number, right? It's not specific double, float, in short, whatever. It just says number, and string is just a string. Here it's quite obvious the title is, well, a string, right? Super straightforward, and that's the uniform structure, right? That you need to commit to in this particular case. It's always user ID, ID, title, body, user ID, ID, title, body, and so on, right? So, but fundamentally a list, because the outer braces delineate this. Yeah, exactly. So it's going back to the this one. Coming back to our beautiful country representation, you guessed it. What's the structure here, as far as you can identify it? Someone else? Of course, we don't have a complete overview, but I think it gives a tentative idea.
the map thing. There's some maps.
So what's on the outermost? What's the outermost structure?
List.
It's a list, correct, right? Square brackets. List of what?
Some maps.
Of maps. Okay. Is that all?
No, and one of the entries, one of the values of the maps.
Yeah.
Is a list.
Correct, right? So you can have nested representations as well, right? So in this case, it's a list of maps containing potentially lists, right? And probably also containing maps somewhere. No, it doesn't. So far, it's all. Oh, hang on. Here is a nested map, right? So it's a nested map containing. And that's the whole structure about, right? So you can combine maps and lists effectively, but it allows you to represent generally, structs, meaning objects, fields, and their values, of course, maps as you know them, and simple lists and arrays, of course. Any question regarding this? This is a very crude outline. I'll point you to JSON.org for the full specification. They have some more of those nice pictures that I kind of had there that highlight the structure a bit more. On. I think it's JSON.org. Was it correct? Yes. Lucky us. Thank you. So if you go through here, you get a bit more of a complete description, but fundamentally it's similar to what you saw on the slides there, describing what the whole language is about and how complex it can be, what a string consists of, which symbols are allowed not in strings, for example, what is allowed in numbers. You see that a number can have some sort of sign initially anyway, can be digit from 0 to 9, can be separated by the decimal place, followed by a digit again, can also have exponent representations, scientific representations of exponents. What is a white space? Can be a space, a line. So it's very, very explicit on the symbolic level, on character level, what can be what. But fundamentally, semantically relevant for us is to understand the high-level aspects, right? So what's an object, what's an array, and what's the value? Those are the three components you kind of want to know about. And then you can build arbitrary structures using JSONs. And the best way of doing it, I feel, is just querying some REST services and see what they spit out, because that's always or usually compliant JSON, right? If you want to validate that your JSON actually works out as well, just look for JSON validators, and they usually allow you to copy and paste your stuff in there, and they will just say, yeah, that's valid JSON or not, right? So it's worthwhile, especially if you're learning about it, you want to try it out. You can be very, use that as a basis for exploration. Okay.
It tells you if it is JSON or not.
It will tell you if it's valid JSON or not, right? So, okay, say, let me do it a bit wonky. Plus H. So let's do it. Is that valid JSON or not?
No.
Good. Well, and it says already, right? So it picks up on exactly the issues. One of them is that the key is not a string, should be, a name should be a string, and that there's a comma after the last entry, right? So there should not be a comma there. Other than that, it'd probably be all right. So it's actually quite helpful in debugging this thing. Let's just do the proof to the example, and it should validate now it's okay, right? So that's the key idea. Use this to debug your output sometimes, especially if you get weird feedback from Go or the parser doesn't work. This is a way to debug it, so you ensure that you get meaningful.
Does it show you the output too? If you want to test things and you want to see the output of your code, does that web page show you the output of what you wrote?
It just shows you what it passed, whether it's valid or not.
Okay.
So what it did here in the previous case, it gives you, quite helpful actually, it gives you some indicator of what is wrong, what is non-compliant with standard. The only thing that it does, there's no code processing, it's just a data structure representation. The only thing that you tell it, hey, please test it against RFC standard, you guessed it, whatever, right, for 4627. So if you want to learn more about JSON, guess where to look, we now know. But that's all you do. It's only about data structures, what's in your body of your request when you're interacting with the service. All right, how do we do this in Go? So I think Mariusz briefly talked about building web services in Go, did he? Yes, no?
Yes.
Yes? Okay, did he talk about REST in Go?
No.
Good.
No.
Okay. So it's relatively straightforward. So if you have this package already, it makes things a tiny bit easier. So fundamentally straightforward here, instead of building it. So main function. I put this whole project, by the way, into GitLab as well, so you can just clone it yourself and have a look at it. It's a bit more extensive there. It retrieves the environment port. The reason for this is secondary, because sometimes I tend to store the port in an environment variable. That's the only way. That's one way of retrieving environment variable. In this case, name port. Retrieve the environment variable and assign it to the port variable here. But that's not really relevant. So what's more relevant is that you have a specify some sort of handler. So right now it's really about laying out the API, literally, right? So an API always starts with root, right? So similar to that, fast as we know, this is basically where everything happens. So after the host IP and the port number, of course, there's a slash and then something else, right? And that's the path that we want to deal with, that we want to devise here. So the example here is that we're doing is, well, we actually have a handle function that listens on, on the slash, so on the root path basically, and is associated with handler nil. So if you look into the HTTP package, you will see that the handlers always have the same following structure. It's pointing to precisely this one. And this one just has a response writer, so it writes some response to any requester, so when it receives a request. And of course, the request itself, right? Reference to the request as well, so we can actually see what you're getting as input, right? And that's pretty much all you get from a REST perspective, from the system, and you can operate based on this one. It's a good practice to listen on the default handler as well if you don't have any on the root path as well, if you don't have any implementation there. So in this case, what are we doing? Well, here I'm just printing out, we have an invalid request received, that's fine. But here, that's the interesting bit, it's the http.error. And it writes back to the response writer. So what do I return to my requester? It's some sort of error message, some body, and a status bad request. Right, so what we talked about before was what are the few things that we need to think about when we're interacting with the REST web service? Well, we need to know the URL, we need to know body layout, methods, and status codes. Right? Those are the 4 core components. And that's precisely the thing here as well. So if I'm now using my browser, let's use that one. And I think it's localhost 8080. So if I'm just opening that page, well, I get an invalid request here. And that's a good support because it actually literally prints me what I write here, right? And it also gives me some return code. I probably use the Postman because it's much more explicit about the feedback. Right. So it says as body invalid request and a status code, it gives me a 400. Right? 400 meaning client did something wrong, you shouldn't have done what you did. And that's specified here because all the status codes are actually encoded in the HTTP package in Go. So let's see if so if you start typing status or you delineate, you'll see actually, hang on, all the statuses that you need to know about are actually here. 200 is an okay, internal server error is a 500, forbidden, found, and so on, right? So you can basically go through all the different feedbacks, and that's given back to the client. So that's your basic REST web service. Doesn't do much, doesn't do anything in fact, but you can play with this and do some operations. So in the spirit of time,
What is a handler?
yeah. So we got this. So that's in a second. So I'll introduce a second handler, which is kind of a simple extension of this one. So we have another handler now. Okay, and we'll come back to your question. So another handler, well, it does something a bit more sophisticated, right? It consumes a request. It checks for the path in a request. So if you check R, you have multiple components, and that gets closer to the message structure as we have talked about yesterday and today. That any requests in HTTP has a body and a header, and we need to be able to access those ones. It also has a method, for example, a URL. So it's all the components that you want to test against if you write your service available here. So what does it do? Well, it takes the URL path that you have entered and splits it on the slashes, right? So it just looks at the structure. Fundamentally, the idea is there, formulate a greeting based on the provided input as part of the URI. If that thing works out, so fundamentally what it expects then is that you have at least a first name and a last name specified as passed on a part on URI. It takes those then to actually construct a greeting message down here and prints those back to the user, right? So we have fprintf. So this basically is a formatted printing function that writes back to the writer. So it sends the response to that guy here. So that's what the user gets back, the requester. And this is the content, that's the payload. That's what's showing up in the website. And now coming to the handler idea. So we now have a handler here. Well, how do we use it? Well, we need to kind of hook it into the system somehow, right? So, and the thing is, we can have multiple handlers. The only thing you need to watch out for, they of course need to listen on different paths, right? Talking about the URI layout again, we're now constructing the API in a way, right? So localhost port 8080, and then we, from there on, that's up to us what we actually want to have there. So which handler deals with the path hello now? Well, the idea is now that we use the handler hello to precisely do this, right? So we hook it in. So that's the nice part of actually separating the API layout, right? How the different paths are constructed. In this case, with /hello, /student, or whatever else, and how we redirect it for its processing then in the to the corresponding handler. I just restarted this service right now. I think I did. So if we run now port 8080 again, guess what? We get an invalid request. But if we append hello right now, so what should happen?
Should print out hello world. Oh, what the? How?
Well, it of course goes into the error. Let's go back there. So yeah, assumption is that you specify first name and last name just to construct the message. If you don't satisfy that, well, then the status becomes bad request, right? We again using the built-in constants into the HTTP package, and then send an HTTP error. This is the content of the error, and this is the status we're sending back, right? In fact, I could have inlined this here right now. That's actually not necessary to have the status explicit there. I could just say HTTP bad request, of course. So. Right, so once it restarts, let's see what's happened. So, okay. Right, so now by actually satisfying the requirements, remember it was wanted to split on slashes, right? So, and wanted to have 4 components in the URL. Now, surprise, surprise, we have 4 components. So what I typed here, it may not be very legible again. It's basically, appending hello and then Lars and Hauk for just a minute of example. And this was satisfying, of course, the requirements, and now it actually did what it's supposed to do and construct the return string and send it back to the browser. So basically, that's how simple the interaction in principle works. We're running out of time.
But is it three parts? It's just hello and then Lars and then how? Where's the 4th one?
Yeah, the URL in its entirety contains the host as well.
Okay,
Right, so it's localhost, hello, Lars, and Hauk, right? So it splits on slash. You have 4 parts coming out of it, right? So it's 3 slashes, you're right, but 4 parts. So that's basically the idea. So that's how you kind of build up the whole exercise. Unfortunately, we're running a bit out of time here. Because I wanted to show you a basic example with a more sophisticated API. Well, I'll just do it somewhat briefly, but we'll get there. Hang on. So of course we don't leave it as simple as that is, but actually extend it a bit more. So again, I encourage you to check it out and actually have a look at this code. But just to get the idea. So if we now want to have a bit more sophisticated exercise, where we actually want to process some student information on whatever else, in this case, the implementation of this handler is not in this same file, for example, but it's actually somewhere out here in the in this file API student. So what it fundamentally contains, it opens some sort of student database. I will not go into this. This is basically just a map, a Golang map to store students and their content, but I want to focus on the API interface, of course, because that's more relevant. So if we now go to the handler, recall I linked to handler students from here. Handler function for the path student is simple rest handler student. Let's go back there. Handler student. Again, note that signature is always the same, right? So it's something response writer writing back to the requester, and a request that comes in, a reference to it. And then again, we can use the request and do stuff on it, right? So in this case, we're actually switching on the method. The method is the, as we learned now, one of the REST methods, right? Get, post, put, delete, whatever else. So you can switch on those ones quite nicely. And of course, they are also embedded in the HTTP package as constants. So here, for example, HTTP method post resolving to post, HTTP method get to get, and so on, right? So, and then you can do things with this. And this, for example, if we expect a post request with a given student structure being specified here. So this is how you lay out, structs. You learned that in Go before. Here's a minor event modification. If you want to, so one of the challenges with structs is, of course, that the different fields are capitalized in order to allow external access, and sometimes they may deviate in a JSON representation. So you can annotate in this form here how they should look like in JSON. What would be the JSON key? So this would be basically just a student struct with the fields name, age, and student ID in JSON. So what does this one here do? Well, create me a reference to some struct, and then take JSON, so it's in the package JSON, encoding JSON rather, and create a new encoder operating that sends to the response writer. No, hang on, I'm in the wrong one. I jumped a bit. Sorry. So JSON new decoder is operate on the response request body, of course. So basically, take the payload of whatever came in. The assumption is there's JSON in there, and decode it into that student object there, right? So if that doesn't work out, meaning if there's an error code coming back from the decoder, or rather from the decode call, then spit something out, something like you did something wrong on the client side, because most likely the JSON was not properly formatted, right? And then do some other checks. You can, once the student is decoded, check if it's in the database. If not, then, well, you send again an HTTP error or something like the student already exists. Please use put to modify, right? Put is the REST method to modify existing entries. Again, with a bad request one, something like this. And then you add it to the database, and if that goes sideways, you just send a status internal server error. Which error code is that in HTTP? 500, right? Cool. And if everything works out, you just send a 200, right? Status OK. Right back to the sender, well, status OK. The same here as an example for a get call, right? So we were switching on the method. So the previous method was post, here's get. And this one here is basically creating a response for an individual student. First of all, in the HTTP response, add a content type information. So we're telling the system, we are sending you information back in the following format. So the content type is application JSON. Alternative ways of doing this one. And you basically then do some splitting on the content, but depending on what you actually got, whether you got a call to the main path, so you got a call to localhost 8080 students, you would return all students. We talked about this before. But if you get a specific reference to a student by student ID, 1, for example, then you would reply with this particular student here. Right? So what it basically does here, this one here, is splitting the URL path and figuring out whether you have the number of paths you actually have. Right? So So if this second path part of a split is basically empty, so there's nothing, there's only a string behind the second slash. So if I were to do that in a browser, so if I was only just a slash but no further information, no student ID, such this one, this is of course not found, then it would reply all students. So basically it goes to the database and retrieves all student it has and writes those back to the writer. In other cases it would just write the student with this particular ID that's specified in part 2, meaning the one in this particular case would be looked up. Sorry, to do this, it basically calls two functions. One of them being the reply with all students. And what does it do? Basically, either encodes an empty student into JSON. So now it's JSON new encoder encode as opposed to decode. Take an empty student if there's nothing in the database. So DB count is 0. In all other cases, get all the individual students, append them into this map structure, and then encode them afterwards. Sorry, it's an array structure. And then encode this afterwards into JSON, return it to the client. So basically that's the whole idea. It's fundamentally the wiring up of requests and responses and do something boilerplatey in between. I didn't talk really about the database, I didn't talk about put, I didn't talk about delete, but this should give you an attack point to look at how REST systems could be constructed. I encourage you to clone this thing from the repository, which is linked to our course. So you should find it in the repo in the simple REST path of the repository. Give it a go, run it, and see that it runs in the first place. It's written as a module, so it should be relatively straightforward. Down here, and this has the full example included in there, including the database. You can look and explore it a bit. I think that's not of particular concern, but what is interesting, how the API is linked up with the individual handler for REST calls. What you can do then, for example, is to extend this with a put call, method put, method delete, and so on, and see if you can get that going and try that out. So it's quite, I think, sensible homework. Is anyone terribly lost on what I just talked about? Totally lost? Okay.
Lost. It's a lot of information.
Okay. Yeah. So that's a bit in the spirit of time. It's a bit short. I agree. In any case, I would encourage you to just try to download the code in the first place and get it running, and then we can follow up on this in greater detail. Unfortunately, we ran a bit out of time, but I just wanted to get the REST concepts across. Also, the other thing I wanted to talk about was the assignment which we came up with. I'll delay this a bit and provide the information then afterwards, because we're running, again, out of time. So either I post some video doing so, because I will not be here next week, or Marish will do that. So we'll see how that works out. But we'll come back to you. But in any case, you can have a look at the assignment. It's posted on the wiki already. See if it makes sense to you. Don't necessarily start on it yet, because the assumption is that we need to talk about some details before that. Otherwise, you will have trouble using the external service in the long run.